This video is about the fractional distillation of crude oil, or how we separate oil into its constituent components. Crude oil is a mixture of hydrocarbons ranging from 3 molecules made of 3 carbons all the way up to those with chains of 50 carbons. And the way we separate crude oil is into what we call fractions. These are groups of hydrocarbons with similar boiling points. Now the boiling point is determined by the length of the carbon molecule. The smaller the molecule, the lower its boiling point. The larger the molecule, the higher the boiling point. Now, we are not allowed to use crude oil as it is because it's carcinogenic, so we have to use what we call synthetic crude oil. This is a mixture which we make up ourselves to use. Now, this is the equipment we're going to use. We're going to use a flask which has got mineral wool in, which has been soaked in the crude oil. It's a sidearm flask with this delivery tube which will come down and into the beaker of water, which will condense the various different fractions. For each fraction we use a different boiling point. The position of the thermometer is crucial because the bulb of the thermometer must be directly opposite the side arm, so it takes the temperature of the gas as it distills out, passes over to be condensed. So let's get started. So the first fraction that I look to collect will be up to about 70 degrees. Now that will be a mixture of petrol and molecules of a similar size and similar boiling point. So this is going to be about C molecules with 8 carbon atoms in, up to molecules with about 12 atoms in. We use a very high scale thermometer. This goes up to 360 degrees because because the last fraction we're up in that sort of range. So once I get the temperature up to about 70 degrees, what I must do is then control it and keep it at that. Now, as you can see at present in the flask, that it's beginning to vaporize. So soon we'll get some starting to condense over. So I'm going to reduce the flame to keep the temperature constant. This is a sample from our first fraction. This is the petroleum, and as you can see, it's fairly colourless, you should expect. It's also very runny because it's the smallest chained sample that we will collect, or smallest chain fraction that we will collect. Now, what we will do then, we will carry on and do a second fraction which will be up to 120 degrees, holding the temperature there. Then a third fraction we will go up to 180 degrees, hold the temperature there and collect whatever we got. And then finally we will get a fourth fraction at 260 degrees and collect that. The last fraction, the bitumen, which we got to about 350 degrees, because it's so thick, it's very difficult to vaporise. We will just use what's left in the bottom of the flask as bitumen and use that. So let me remind you, so this is fractional distillation. We're separating mixtures of hydrocarbons. We're separating them in terms of their boiling point. The boiling point depends upon the size of the molecule. The larger the molecule, the higher the boiling point. Because it would be very difficult at this stage to separate all the individual hydrocarbons. We separate them into fractions. Fractions are groups of hydrocarbons with similar boiling points. Those fractions will later be separated to get the individual pure hydrocarbons. So that's our fractional distillation.